Hey guys, in this video I'll be talking about the concept of power factor within the electrical engineering discipline. The power factor is generally defined to be the ratio of the real power flowing into a load and the apparent power, which is also denoted as the wasted power. It is useful in life practices today as it can be used to correct the wastage of power. Here we can see that the power factor is equal to the real power over the apparent power, and in units is watts over volt amperes. The power factor is also equal to cosine of theta, which is proved in this triangle here. If we make the apparent power equal to S, the real power equal to P, and the reactive power equal to Q, we can find that cos of theta is S over P. On the right side of the page over here, we can see how I derived this formula. You can pause and take a look for yourself. When calculating the power factor, we use the RMS values of current and voltage. When we look at the power triangle into more depth, we see that the apparent power is equal to the RMS current squared times the impedance. We can see that the true power is the RMS current squared times the resistance, and we can see the reactive power is the RMS current squared times the reactance. Now to look at an example. Here we are given a simple circuit is constructed with a power source of 80 volts at 30 Hz, a 20 ohm resistor, and a coil that is wound containing an inductance of 150 millihenries. We are asked to calculate the current, the power factor, and the phase. Given the data provided, we can use Ohm's law of voltage equals to current times the impedance, which then can be arranged to find the current. The impedance is also known to be equal to the square root of R squared plus the reactance squared, which we find the reactance to be over here using 2 pi times the frequency times the inductance. Therefore Z is equal to 34.7 ohms. Subbing in our values, we find that the current is equal to 80 volts over 34.7 ohms, which is equal to 2.3 amps. Now that we've found the current, we can use our knowledge of the power triangle to calculate the real power and the apparent power. And now we put the real power over the apparent power to get the value of 0.576. And that's our answer for the power factor. And now using the answer for the power factor, we can take the inverse of cos of the power factor to find the phase angle. Here is a summary of the content explored within this video. Thank you for watching.